Okay, so our lesson is about integration by partial functions. So, what is a partial function? So, a function that is f of x is equal to f of x over gx. When f of x and g of x are polynomials, this is called rational fraction. Sorry, rational fraction. So if f of x and g of x are polynomials, it is called a rational fraction if f of x is less than the degree of g of x. So if f of x is less than the degree of g of x, the f of x function is called proper. Otherwise, it is called improper. So, ano yung improper? Improper is that when f of x, the degree of f of x is greater than of g of x. Example is that if our function is equal to x cubed over x squared plus 1. So, this becomes an improper rational fraction. Why? Because the degree of f of x is greater than the g of x. So, an improper rational fraction can be expressed as the sum of a polynomial and a proper rational fraction. So, this can be expressed as x minus x over x squared plus 1. So, an improper rational fraction, that is x cubed over x squared plus 1, can be expressed as a polynomial and a proper rational fraction. A proper rational fraction. So, a proper rational fraction is that the degree of f of x is less than the degree of g of x. So, every proper rational fraction can be expressed at least as a sum of a simpler fraction. So that simpler fractions is called partial fractions, whose denominator are of the form of ax plus b raised to n and ax squared plus bx plus c raised to n, as n being a positive integer. So there are 4 cases depending upon the nature of the factors of the denominator that will arise. So we have case 1. In case 1, it is called distinct linear factors. So to each linear factor ax plus b occurring once. So distinct linear. Okay, it is occurring once because it is distinct. In the denominator, it is occurring once in the denominator of a proper rational fraction. This corresponds a single partial fraction of the form a over ax plus b, where a is a constant to be determined. Example, we have 1 over x squared minus 4. And we know that x squared minus 4 is x minus 2 times x plus 2. So we can express that 1 as a over x minus 2 plus b over x plus 2. And then we're going to determine the constant that is a and b. So that's for case 1. And for case 2, repeated linear factors, to each linear factor ax plus b occurring n times. So in the case 1, the factor ax plus b will occur once, while in case 2, it will occur n times in the denominator of a proper rational fraction. This corresponds a sum of n partial fractions of the form a sub 1 over ax plus b plus a sub 2 over ax plus b squared until a sub n over ax plus b raised to n, where a's are constant to be determined. Example, we have 2x plus 5 over x cubed minus x squared minus x plus 1. That will be equal to 2x plus 5 over x minus 1 squared x plus 1. So we know, class, that in this equation, in this function, x plus 1 occur once, but x minus 1 occur twice. So, ang gagawin natin, kunin muna natin yung mag-occur once, that is a over x plus 1 plus b x minus 1 plus cx minus 1 squared. So, and then we're going to determine the constants a, b, and c. So, next we have case 3, distinct quadratic factors. So, quadratic. Wrong spelling ako. So, quadratic. So, distinct quadratic factors. To each irreducible quadratic factor, ax squared plus bx plus c, occurring once. So, pag distinct, occurring once. Pag repeated, occurring n times. Occurring once in the denominator of a proper rational fraction, this corresponds a single partial fraction of the form ax plus b over ax squared plus bx plus c. So, bakit naging ax squared plus bx plus c? Ibig sabihin, it is an irreducible quadratic factor. We cannot reduce it into a linear form where a and b are constants to be determined. Example, we have x squared over a raised to 4 minus x raised to 4. That it will be equal to x squared over a minus x times a plus x times a squared plus x squared. So, we have distinct linear factors here, a minus x and a plus x. And we also have a quadratic factor class, that is a squared plus x squared, occurring once. So, that's why it is distinct. And for case 4, for repeated quadratic factors, to each irreducible quadratic factor, ax squared plus bx plus c, occurring n times in the denominator of a proper rational fraction, this corresponds to the sum of n partial fractions of the form a sub 1 x plus b sub 1 over ax squared plus bx plus c plus a sub 2 x plus b sub 2 over ax squared plus bx plus c raised to 2 until a sub n x plus b sub n over ax squared plus bx plus c raised to n, where the a's and b's are constants to be determined. Example, 2x squared plus 3 over x squared plus 1 squared is equal to ax plus b over x squared plus 1 plus cx plus dx squared plus 1 squared. Why, class? Kasi obvious naman that the quadratic factor is x squared plus 1 and it is repeated twice in our equation. So, if we encounter this class, if we're going to integrate this equation, ang gagawin muna natin, i-convert muna natin into a simpler, proper, rational, into simpler partial fractions para mas madali tayong mag-integrate. Okay, so, we have example number 1. So, in example number 1, the integral of dx over x squared minus 4. So, mahirap siyang i-integrate kasi hindi naman natin siya ma-integrate by method of substitution. So, we are going to i-separate muna natin siya. Gagawin muna natin siyang 1 over x squared minus 4. And we know, class, that x squared minus 4, makukuha natin yan by x minus 2 times x plus 2, which will be equal to partial fractions a over x minus 2 plus b over x plus 2. And then, ang gagawin natin, i-multiply natin each side of the equation ng kanyang denominator. So, that means makakancel dito sa 1, magiging 1 is equal to a x plus 2 plus b x minus 2. So, pagsasamahin natin yung like terms like x. So, ano ang x? That is ax plus bx. So, we can write it as a plus b times x plus 2a minus 2b. Ngayon, ang gagawin natin is we're going to equate, class, yung equate coefficients of like powers. So, sample, since x and constant lang naman to, ang gagawin natin, kunin muna natin yung sa x. Sa x, ano ang value ng x dito sa ating left side? Value of x is 0. Ano yung value naman ng, ano yung meron namang x dito sa ano yung merong x naman dito sa right side? That is a plus b. So, 0 is equal to a plus b. So, we can say that a is equal to negative b. And then, for constant class, ano yung meron sa left side ng constant? That is 1. Ano naman yung meron sa right side na constant? That is 2a minus 2b. And since na-equate na natin from our previous equation that a is equal to negative 2b, we can say that 1 is equal to 2 raised to negative b minus 2b. That will be equal to 1 is equal to negative 4b, where b is equal to negative 1/4. Since b is equal to negative 1/4 and a is equal to negative b, that means a is equal to 1/4. So we are going to say, to substitute class, that 1 over x squared minus 4 is equal to a 1/4 over x minus 2 plus negative 1/4 over x plus 2. That is 1 over 4 x minus 2. Okay, palitan natin. That is 1 over 4 x minus 2 minus 1 over 4x plus 2 equal siya sa 1 over x squared minus 4. So, balik tayo dun sa ini-integrate natin class, that is dx over x squared minus 4. Pwede nating isulat na, i-separate natin dx over x minus 2. Labas na lang natin yung 1/4 minus 1/4 integral of dx over x plus 2. So, ano naman ang integral ng dx over x? Something that is ln, diba? So, ang gagawin na lang natin, integral of dx over x squared minus 4 is equal to 1/4 ln of x minus 2 minus 1/4 of ln of x plus 2 plus the arbitrary constant c. Okay, so pwede nating pagsamahin yung ating ln, pwedeng maging negative 1/4 ln. Pag minus, magiging denominator, di ba? So, x minus 2 minus ln x plus 2. So, ganyan na lang siya. Plus c. And dito, dito negative 1/4. But naging negative 1/4. So, that is 1/4 ln. So, integral of dx over x squared minus 4 is equal to 1/4 of ln x minus 2 over x plus 2. Okay, sulat ko ulit. Ln x minus 2 over x plus 2 plus c. So, that's it. So, mula dito, sa ganito na hindi natin ma-solve, gagawin muna natin ganito.